Hello, this is George C. Bradley, and today's presentation will be on how to run a one-way analysis of covariance using spss. With a one-way analysis of covariance, each individual or case must have scores on three variables: a factor or an independent variable, a covariant, and a dependent variable. Let's take a look at our data set. The title of our data set is called Clinical Trial 1, which is a study on depression in individuals. Our independent variable or our factor is me-primine, and me-primine, a synthetic compound used to treat depression, will equal 1, and the placebo will equal 0. Our baseline depression rating scale will equal the covariant, and our post 6-week depression rating scale will equal our dependent variable. Let's take a look at our outline. Our test for homogeneity of slopes. I'll initially demonstrate how to test the hypothesis of the homogeneity of slopes, which is an assumption of the analysis of covariance. The analysis represents the first step in testing the process when conducting an ANCOVA. The analysis of covariance. Next, I will show how to conduct an analysis of covariance. The ANCOVA evaluates differences in the adjusted means. This step presumes that the initial analysis indicates that the slopes appear homogeneous. We're now in our spss package, and we're going to take a look at our test for homogeneity of slopes. We'll go to Analyze, and then we'll go to General Linear Model, Unit Variance. We will baseline, we'll go to the covariant, me-primine, it's our fixed factor, our post 6 weeks, and this is our dependent variable. Now the important thing here for this assumption is to go to model. We have it in a full factorial model now. We will go to customs, and we'll put each one of these in the model separately, but the most important thing is to get both in there. We have that. We can go to continual. Now we can run it, but right now we know we have to analyze the analysis of variance. So let's put the information in for that. We have our plot, and we can go to our independent variable here and put that in the horizontal axis and add. We don't want to save. We're going to continue. We don't want to save anything right now, so we will put continue there. Our options, we need our options. Display mean, go there. Our independent variable, descriptive statistics, yes. Effect size, yes. Power, yes. And our homogeneity test. And one is to the assumption of the slopes of the regression, and the other one is of the variance. And that's this one here. Okay. All right, now we can click on OK. And as we click on OK, we'll go down here to test between subject effects, and we'll go right here to our independent variable and our covariance. And if we go to significant, we will fail to reject the null. And if this is above 0.05, that is good. That assumption is met. So that's great there. That assumption is met. Let's go back to analyze here. And we can go back to general linear model and unit variance. And we only have to make one adjustment here. We can go to model. And we want to change this to full factorial. And hit continue. And our plot is okay. We just want to check this information just to make sure it didn't do anything here. Right here, we want to compare the main effect. Let's click on there and let's use Bonferroni here. And we can click on there. Now we have everything in place for our analysis of covariance. Now our analysis of covariance here, we can see imiprimine. We have the placebo, that's 53, our synthetic compound used to treat depression, imiprimine, that's 57, and we can see the means not adjusted. And right here we have something very important. We have Levene's test of equality, and that shows that there's no significant differences in our variances. And when that significant value right there is above 0.05, then that assumption is met. As we go down to tests of between subject effect, we can see the baseline is significant, and by the eta square, 27% of the covariant has an influence on our dependent variable. And then the important thing here, there's a significant difference between the placebo and the actual antidepressant drug. And you can see right there that it's less than 0.05, and only 4% influences the dependent variable. We can look at our graph here and can see right here that the depressive rating scale is higher with the placebo than the actual antidepressive drug. Let's look at one more analysis here. Let's take a look at this with an ANOVA without the covariant. We can go here, and what we want to do, we want to take out baseline, and we want to see if it's significant. As you can see right here, it's significant right there, and it has about 1 more % over here with eta squared. So you actually have a stronger model with your ANOVA than you would have with the analysis. Not much, but there's a significant difference with both. And one thing up here that we didn't look at, that we wanted to look at, let's look at our adjusted means here. You got adjusted means different from the actual mean. You have 23 on 0.5, 21.4, and you can see that the adjusted mean are a little different here. As you can see with our presentation, there was a significant difference between the antisuppressive drug and the placebo as it pertains to the depression rating scale, with the baseline being the covariance. If there are other questions, please email me at georgecbradley59@gmail.com. Thank you.